Hello. Security incident investigators work with many data sources like system logs, network traffic data, or data from storages. Regarding data storages, analysts can deal with either complete disk images or with snapshots of file system metadata. Full disk images provide exact copies of storage devices with complete content of file, but they are huge, typically several gigabytes or terabytes. This is why forensic investigators prefer snapshots of file system metadata that provide only limited information because no content of files is available, but they are reasonably small and at the same time they provide sufficient information for the investigation. Let's show it. File system metadata captures the last manipulation with files. In this box below, there is an example for SSHD binary file, but the whole dataset consists of similar records for each file or directory on the disk. In our example, the last manipulation with the SSHD is captured by 3 records using 4 different attributes, MC, B, and A time. The modification time attribute captures the last modification of the content. So we know that at this time somebody wrote to a text file or compiled a binary. As you can see, our file was created at this time, so at this moment the package maintainer probably compiled the binary. The change time denotes modification of access privileges or ownership. Birth time, birth time denotes when the file was created or replaced on the disk. In our example, both these changes were done at the same time, which means that the binary was installed or replaced on the disk. If the order was reversed, the binary was installed first and then modified without replacement, then it would be really suspicious and worth paying attention to, because it would indicate that somebody changed the content of existing installed executable. The access time captures when the file was last read without any modification or when a binary was last executed. Even this simple example demonstrates that the interpretation of the metadata requires deep expert knowledge, and the exploration of suspicious records has to be done in the context of other modifications that are captured in the dataset. And providing support for such visual exploratory analysis was the goal of our research. The dashboard consists of 3 coordinated views, where a change in one view to the dataset affects other parts of the dashboard. The primary part of tool is in sector 8 that handles list of metadata records. I switched video to demonstrate interactions. The analyst can easily skip blocks of records with respect to a given prefix. By selecting a user shared doc prefix, for instance, we can skip back and forth to the previous or next directory. The same principle works also for timestamps, where we can skip by year, month, hour, and so on. Records can be highlighted or even filtered out temporarily as well. As the list displays only a limited number of lines, the current span is reflected in the upper timeline in the form of sign stripe. If the analyst scrolls up and down, then the stripe updates accordingly so that we know what part of the span is actually displayed on the screen. The upper part of the dashboard provides an aggregated view of timeline. It consists of bars denoting the number of available records spread over time. If we zoom in or out, then the timeline automatically switches its granularity from years to months, weeks, days, and so on, and the bars are recalculated accordingly. Details of bars are provided on demand as tooltips. By clicking on bar, the list scrolls to the beginning of the data. Records of high importance can be bookmarked in the list view. After that, they are emphasized in the list and displayed in the histogram as pushpins. Pushpins that are too close to be shown separately are merged into a single symbol with the number of such aggregated pushpins. Because bookmarks represent key records for the evidence and provide important context for the analysis, then they are always presented in the list of records, even if they would be potentially hidden by filtering, as I will show you now. Filtering is possible on the per attribute basis. Individual attributes are represented by different colors in the histogram. Another filtering is possible with respect to time windows. Several spans can be drawn and managed in the histogram. They can be easily shrinked or stretched by days, weeks, and so on to provide narrower or broader context. The analyst can focus on selected time window, directly manipulate with them, and so on. The third part I'd like to introduce consists of so-called clusters. Clusters represents a generic mechanism enabling analysts to select files or directories with a specific like fingerprint. They are defined by the combination of file system attributes and location in the file system. Together with domain experts, we predefined several clusters that we suppose to be useful, like privileged executables, hidden files, or files denoting compilation signs, but it's possible to define new clusters as well. Currently, only one cluster can be applied at a time, but we already work on the version where the combination of clusters will be possible. When a cluster is selected, then the list of records is filtered with the exception of bookmarks that are always preserved, as I already explained. The number and stripe in each cluster indicate how many records are available in the dataset fulfilling the cluster criteria. This is the higher number versus how many of them are actually available in list view with respect to other filtering options like the span restriction, for instance. Therefore, the analyst can glimpse the impact of each cluster very quickly and prioritize the usage of clusters according to the number of related records, for instance. To prove the usability of our tool, we invited 5 professionals who work in the cybersecurity domain, but not all of them had experience with directly with analysis of file system metadata. So we covered both experienced and less experienced users. We used a real incident with quite typical attack vector, but with individual pieces of information hidden in the amount of data and not really easily observable. Analysts have never seen the tool, nor the incident of course, therefore we familiarized them with the interface first, which took roughly 20 minutes. Then they analyzed the incident, aiming to summarize what happened and when, in their words. We restricted the analysis phase roughly to 1 hour, wondering how much information and in what detail they would be able to provide. And we were quite surprised. First, we evaluated generic usability using standard system usability scale method. The final score 88.5 indicates excellent usability of the tool, which is great. We also tested precision of the investigation results. The attack scenario is summarized in the upper box in the form of 6 stages that we observed in the data. It's as follows. The attacker used the account Martin to get in remotely by SSH. Then he installed a Trojan code to the system by changing system configuration and one system library. Then the attacker compromised also the account of user Roberto, probably as a backup entry point. The attacker probably was not satisfied with the Trojan code because he recompiled the code on the host and reinstalled it. He also created a hidden directory where he compiled suspicious tools and where he stored results of massive network scans. And finally, the system accounts were modified, probably a new user was added. The bottom table summarizes how much the analysts were able to observe these 6 steps. The black circle means fully observed step with sufficient details. White means overlooked step, and black and white circle denotes for a partially described step. After the real investigation usually takes many hours or even days, and our respondents were limited to only 1 hour, the table clearly shows that still they were able to recognize most of the attack scenario, often in very surprising level of details and precision. The only problem they faced was with the 4th step, which was the recompilation and reinstallation of Trojan code. To get even better insight into the usability, we used a simple easy question evaluation method where the analysts rated how much the tool helped them to solve 6 particular analytical tasks that we identified together with domain experts and which were part of the investigation process. They considered the investigation of suspicious files, privileged executables, the usage of unusual commands, and possibly compromised users as very easy with our tool. The identification of system files probably modified by the attacker was ranked as rather easy, and the only identification of executables that were not installed from its package was considered difficult, which pretty corresponds to our previous results where this step in the attack was overlooked by most of the analysts. During the evaluation, we noticed that the users significantly differ in the way how they use the tool or in general in their investigation strategy. Therefore, we explored their interactions that we recorded and measured how much time they spent by using 5 major visual or interaction artifacts. Filtering by name, by span window and attributes, and using clusters and push pins or bookmarks if you like. As you can see, all the analysts preferred the combination of only 2 or 3 artifacts that they used intensively and mostly overlooked other features. But we didn't recognize any pattern like that there would be some preferred combination or combination that would lead to better results or something like that. Anyway, this observation suggests that our tool doesn't restrict analysts in their investigation strategy, but still significantly help them in the investigation, which is great. The results of the evaluation convinced us that the tool is easy to use and is useful. The analysis is efficient even when conducted by less skilled analysts. However, we also got a useful feedback and ideas for further improvements. For example, we noticed that multiple analysts forgot to cancel the per attribute filtering during the investigation, which led them to false hypotheses and then delays in the investigation. Therefore, some kind of better indication of these filters is required. Another point is related to bookmarks. Current bookmarks are represented as push pins, and they are very simple and used primarily for fast navigation. But multiple analysts were asking for the possibility to distinguish between them by color, tagging them, making their own notes, searching in bookmarks, and so on. This change from simple bookmarks to something like advanced annotations would be useful for the automatic generation of incident reports directly from the exploration process. That would shorten the time for investigation. File system metadata represents only one source of information, especially so-called super timelines that combine file system metadata with system logs are often used in forensic analysis. As both file system metadata and system logs represent time series, then the extension of our tool would be possible and valuable. However, further research and evaluation are needed in the future work. Okay, that's it. Thank you for your attention, and I'm ready to answer your questions.